Bismillahirrahmanirrahim. Pka Physics Form 4, 24 September 2022. So the first one, the technique to answer is we circle important information. So we have 4 meters and the density is 1000 kilogram per meter cube. So pressure in liquid, we have to remember this equation is equal to rho density G times depth. Okay, so 1000, G is 10, depth is 4 meters, so this will give us 40,000 Pascal. So 40,000 is equal to 4 times 10 to the power of 4 Pascal. So dynamic, right? So number 2, the diagram containing oil, so it's not water, so the density is different, 900 kilogram per meter cube. So again, pressure in liquid is equal to density rho times G times depth. So density is 900, G is 10. So to find the depth must be from the surface of the water to the point. So it's equal to 2.8 minus 0.8. This one equal to 2. So this will give us 1.8000 Pascal. So this is equal to 1.8 times 10 to the power of 4 Pascal. So this is B. Second one, third one, the pressure. So we have pressure this time and we have density. So again, same thing, pressure in liquid equal to density times G times H. So pressure is 5 times 10 to the power of 7 Newton per meter squared. This one is equal to Pascal. Newton per meter squared is actually Pascal, times density 1.02 times 10 to the power of 3. G is 10, so the depth is H. So we rearrange, is equal to 5 times 10 to the power of 7 divided by 1.02 times 10 to the power of 3 times 10. So this will give us depth is equal to 4.9 times 10 to the power of 3 meter. So we got C. Number 4, we have a submarine, 3000 meter depth, so 3 kilometers, and we have density. We want to calculate density of seawater. So just now it should be around 900. So let's see. And we have the pressure. So again, same equation, pressure in liquid. So the equation actually repeats so that you can remember the equation. 3.09 times 10 to the power of 7. So we want to find density. G is 10 and depth is 3000. This will give us the answer is 1.03 times 10 to the power of 3. Alright, sorry, 900 is oil. Density of seawater is greater than water. Water is 1000. So 1.03 is greater than 1000. Alright, number 5. We have water tower. Why? This is the equation why we put water tower at higher place, so that we got higher water pressure. Okay, so we want to find the pressure of the water in the tank. So this is the water in the tanks. So the depth here is H is equal to 25 plus 5. So that is 30 minus 10. So is equal to 20 meter. Right, so we want to find the pressure. Pressure in liquid again equal to rho GH. Rho is 1000, G is 10, and height is 20. This will give us 20,000. 2 times 10 to the power of 5. Sorry, 10,000. Sorry, 200,000. 200,000 Pascal. Right, number 6. So we have piping systems. Same thing, why we put water tank at the top of the building, so that we got higher water pressure. So we want to find the water pressure in the X house. So X is here, so the depth is 212. meter is the depth. So again, pressure in liquid equal to rho GH. So rho is 1000, G is 10, and the depth is 212. Right, so we want to find the water pressure. Okay, if you want to find the total pressure, we need to add with 1 times 10 to the power of 5 Pascal. In this case, we don't have to add because we want to find water pressure only. So this will give us the answer 2.12 times 10 to the power of 6 Pascal. Okay, so the answer is C. Number 7. So we have identical containers. So we have identical containers but different liquid, M and N. So the depth of the liquid is 60 cm for M, but we don't know the depth of N, right? But it's put the same distance. Okay, this distance shows pressure. Okay, so because the both beakers put the same distance means both pressure at height 60 cm and at height H have same pressure. Okay, so pressure in liquid again equal to rho GH. So in M we have rho is the density of M is 2, the G is 10, and height is 60 cm. Okay, we can use cm here. And in N, so because same pressure, so we want to find the density is 1.5, G is 10, and the depth is H. Okay, so we rearrange the equation. We got 2 times 10 times 60 cm equal to 1.5 times 10 times, that is all. So we can cancel out 10. So we got H is equal to 80 cm. Alright, so 80 cm. Okay, so the distance of the water spurt is representing the water pressure. Number 8, diagram shows liquid in containers. Which column of liquid exerts the greatest pressure on the base of its container? Okay, so we can use both. Actually, we can use P equal to F over A. We can also use P for liquid equal to rho GH. But here, if we use F, so F is weight. Okay, so we have to find the weight over area. Okay, so it's easier to use this one. So for the first one, we got 2500 Pascal. B, we got 3400 Pascal. So all of these I use P equal to rho GH. C, we got 4000 Pascal, and D, we got 5000 Pascal. Okay, so we need to calculate all 4 containers. Right, number 9. So again, we have water tank at the top of flat. What is the correct comparison? Alright, because pressure in liquid equal to rho GH, so the difference between P and Q is depth. Okay, so Q higher depth, so higher depth, higher pressure. So pressure at Q is higher than pressure at P. Okay, higher depth, higher pressure. Okay, so it's a depth. Again, it's a depth, not height. If we look here, the height of P is greater. Okay, so H here is depth from the top to the bottom. Right, number 10. Which one is not true? Not true. So it's all about pressure in liquid. So pressure in liquid is equal to density times G times H. Alright, so we all are increasing if the depth is increase, correct. If density increase, correct. Gravitational acceleration increase, correct. So surface area, no surface area in the equation. So surface area does not affect the pressure in liquid. Doesn't affect, right? So that is the one not true. So we need to make sure we completely notice that we want the wrong statement. Right, number 11. So we have water spurts. Okay, so this one shows that lowest pressure because shortest distance, and this one is highest pressure. Okay, again we answer same type of question just now. So the smaller the volume of water, so it's not about volume, it's about depth. Alright, so this one is wrong. The greater the depth, the greater the pressure. Right, so the answer is C. Right, number 12. Water spurting again, and we have depth H. So which graph shows the correct relationship between pressure and the depth, right? So if we look at the equation, P in liquid, pressure is equal to rho GH. So pressure in liquid is directly proportional to depth. Okay, so the graph of directly proportional should be like this. So pressure times depth. So the answer is D. Okay, so this one is decrease. Okay, decrease linearly. C is increase linearly, and this one is increase maybe quadratically. Okay, quadratically. Okay, so if you look here, for example, if we have P4 and depth is 2, so let's say at P8 we got H is 4. So we can see here as P increase, depth increase. Okay, number 13. So we have W, X and Y in river water and sea water. So we want to find the correct comparison. Okay, which one is higher pressure? Okay, so we have river water density is lower than seawater density. Okay, so between W and X is higher pressure. Between X and Y, because X and Y same depth, okay, but different density, so Y is in higher density liquid, seawater, so pressure at Y is bigger. So the answer is A. Number 14. So we have 3 similar containers, same height, same depth, sorry, not height, depth, same depth, but different liquid. So we have pressure in liquid equal to rho GH. So this one is constant, but we have manipulated the density. Okay, which one will expand faster? So it's like a spurt of water. Okay, so if higher pressure will expand faster lah. Okay, higher pressure, so higher pressure, higher density. So which one is higher density? So oil is the smallest density, and then water, so the highest density is salt solution. So the answer is F. Okay, number 50. So we have diesel funnel, right? So we do the experiment on Earth. So what will happen if we have what will happen to this H if we have the diesel funnel, same level, same depth, so same depth, but the apparatus is carried to the surface of the moon. Okay, we need to notice that actually this is pressure in liquid. So pressure in liquid, so is equal to rho GH. and also here is pressure in liquid, so pressure in liquid is equal to rho GH. Let's say this one is the liquid number 1 and this one is liquid number 2. Okay, when we bring to the moon, so over here, so I will write down in blue, so pressure in liquid here is the same. Okay, same. Okay, so when we go to the moon, pressure in liquid here, density is the same, but gravity of the moon and the depth is the same. And for this one, pressure in liquid, so density is the same, gravity of the moon, and you want to find nu h if there is nu h. Okay, so if we go back to the earth, so we have on earth rho 1 GH is equal to rho 2 GH. So we cancel out the G, so we find that H is equal to rho 1 small h divided by rho 2. Okay, so that is on the earth. And if we go to the moon, so we have rho 1 G moon and depth is equal to rho 2 G moon and nu h big H if there is any. So we find that H2 is also equal to rho 1 same depth over rho 2, so same value, so there is no change of the depth. Okay, you can repeat this one or you can contact me if you want to a slower version of explanation, for example. Right, number 16, so we have water spurt again from crumpled tin can. So which of the following is correct spurt? Okay, so the answer is B. This one is quite simple. Number 17, so we have different containers but with same water level. Okay, so the pressure caused the water, okay, so caused by the water at point PQR. Okay, so because all are filled with water, so density is the same at the same place, so the only manipulated variable is depth manipulated variable. Okay, the depth is also the same. Okay, so depth is the same, so there is nothing changed. We don't change the density, we don't change gravitational acceleration, we don't change depth, so there is no change, so all are having the same pressure. Number 18, so we have equal mass of water into 4 jars, in which jar the pressure exerted by the water on the base is greatest. So in which jar the pressure exerted by the water on the base, okay, so outside here, so its equation used is P is equal to F over A. So all are having the same weight but different area. Okay, same weight but different area, so smaller area will give greatest pressure, so the answer is dynamic. Number 19, we have water container before being tilted and after being tilted, so we can notice that slow water here, slow water means low pressure, faster water here, fast water means higher pressure. Why higher pressure? Because deeper ataupun high depth. Okay, so it depends on the depth, so the answer is C. Last, number 20, so we have a U-tube filled with 2 liquids X and Y that do not mix. Okay, so we want to find the density of liquid X. So if we look carefully, they do not mix and X is at the X is above the Y, so we can expect that density of X is lower than density of Y.
With
That
Music
is
Premium,
one of
it's a
the
portal to
information that we
download
got.
songs and listen
Okay,
anytime you want offline.
so
So you
at
can
this point,
anytime,
so here
Get YouTube Music
we got,
Premium. Try 1
sorry,
month free of
need
charge.
to, okay, so pressure in liquid here is equal to the pressure in liquid here. Okay, so over here we have rho GH and rho is 0.9, G is 10, and the depth is 4 cm. So it's equal to pressure over here, rho GH. Okay, so the rho in X we want to find, G is 10, depth is 12 cm, is equal to 0.9 times 10 times 4 cm. Okay, so cancel out 10, so we have rho X is equal to 0.9 times 4 divided by 12 cm. So cm and cm we can cancel. Right, so the answer is we got the answer is 0.3 grams per centimeter cube. Okay, so it's the first part. So you can repeat this video for each question if you want to understand, or you can contact the teacher. You can contact me if you want more explanation. Alright, number 29. So this one is a subjective question. So we have diagram 29.1 and 29.2. Similar vessels. Okay, so we underline that, similar vessel. One hole are filled with oil, so we change the density. Okay, so we can see the oil spurts shorter distance, water longer distance. So what is the meaning of pressure? So it comes from the equation P is equal to F over A. So P is pressure. So this is how you answer this question. P is pressure, F is force. You have to write all of this. A is area. Okay, so the sentence is pressure is the force over unit area. Okay, so if you can answer like this, you will confirm get full mark. Okay, because both is the way to answer. Both are the ways. Alright, so second one we have 5 marks, so we need to compare. Okay, so 5 marks means 5 points. Okay, so we need to find all those 5 points, so we need to make sure we don't lose mark. So we want to compare the depth. So the first one is the depth, the second one is density, and the third one is the distance. Alright, so we have 3 marks there. And the fourth one is relate distance with pressure. And the fifth one, the final one, is to deduce the relationship between density of liquid and pressure. So we have 5 points, right? 5 points. 1, 2, 3, 4, 5. So we need to have that 5 points here. So the first one, compare the depth. So same depth of both containers. Right, the second one is about density. So if you look, density of oil is smaller than density of water. And then the third one is about distance. So we can see distance spread by water is longer. And then number 4, distance and liquid. So more ataupun longer distance, higher pressure. And the last one is about density and pressure. So higher density higher density, higher pressure. Okay, so that is the deduction, because we can see here. So first one, we have the same depth, so that means the depth is constant variable, but we change the density. So oil is lower density, and water higher density, and water have bigger distance, means higher density higher distance, and higher distance higher pressure. Okay, and B. So we have liquid in pressure. Using equation pressure equal to rho GH, derive the equation. So we want to derive pressure equal to rho GH from the equation P is equal to F over A. Okay, so from that we can see F is weight. Okay, weight is equal to mass times gravitational acceleration. Okay, and area, okay, if we have a box, okay, area, so this one is area. Okay, so if we times the height, so volume is equal to area times height. Okay, so if we put the equation, so area is equal to volume divided by height. So from that, if we use equation P is equal to F over A, so F is equal to mg, and area is equal to volume over depth, height. Okay, so if we arrange this equation, we got equal to mg times h over volume. Okay, over volume. Okay, and density is equal to mass over volume. Okay, mass over volume. So we have mass over volume here. So from that we got pressure is equal to, if we rearrange the equation again, mass over volume times G times H, and mass over volume is equal to density, so rho GH. Okay, that's quite interesting. And the final question is about a dam. So we want to design. Okay, so this one is actually higher level lah. So if this is for your PBS, pentaksiran berasaskan sekolah, so if you can answer this question, you can get tahap penguasaan 6. Okay, tahap penguasaan 6. So it is 10 marks, so we need 10 points. Right, so I will answer with blue pen. So let's see how to answer this type of question. Okay, so 10 marks comes from 5 characteristic, 5 character with 5 reasons. Okay, 5 reasons. So we have characteristic, okay, and then reason why we design it that way. So the first one, I think we should make the dam higher. Okay, so that we got higher water to fall, so we get higher velocity. Higher velocity will rotate the turbine faster. Rotate turbine faster. Okay, so we want to make the dams higher wall of dam. Okay, to have higher gravitational potential energy of water. Okay, that's the first one. The second one, we want to make the dam thick, dam wall thick at bottom. Okay, so the wall is like this, so it is high and then it is thick at the bottom. So here is the water. Okay, so thick at bottom because higher water pressure at the bottom. Alright, and then we can also make the characteristic of the wall is material concrete. Okay, concrete, because so the reason is because not rusting, strong. Okay, and then about the turbine. Okay, so another two characteristic from the turbine or the penstock. Oh sorry, we want to make about the penstock. So I think the penstock should be from above, okay, not from the bottom, from above, and then it will hit the blade of the turbine. Okay, so penstock is at higher place, okay, so that higher gravitational potential energy. Okay, so this one will produce more electrical energy. Okay, electrical energy, because energy cannot be created, cannot be destroyed. So higher gravitational potential energy will produce higher electrical energy. Alright, and the last characteristic is turbine at the bottom. Okay, so we want the water at higher place possible, and we want the turbine to be at the lower place possible. So turbine at bottom. Okay, so we will have water at higher kinetic energy. Alright, again that I repeat all the 5 characteristics. Number 1, number 2, number 3, number 4, and number 5. So that are 5 characteristics with 5 reasons to get 10 marks. Again, you can contact the teachers, can contact me. Right, my phone number 01946000417 if you want more detailed explanation. Right, thank you, bye.